So you may be someone who's just finished your GCSE Maths exams or assessments, however you've been assessed at school. And you may be going on to do A-level Maths, however you may not feel too confident, or you may be looking to learn the key skills that you're going to need. So the idea with this video is we're going to take a look at some transition, sometimes known as bridging material. So making that gap between GCSE to A-level Maths. What are the key skills? Well, in this video what we're going to do is we're going to go through a number of sections here, a few questions from each section, and basically these are the kind of key skills that you want to be confident with going into A-level Maths. This video alone is not going to prepare you for A-level Maths for the whole year, but it'll help you get off to a good start with A-level Maths. So let's take a look at section A, which is looking at rearranging formulas and formulae. So this is a very, very key skill in A-level Maths. The idea here is that we want to make something the subject of the formula, and this is important in A-level Maths because we'll be doing it in stuff like mechanics, and you'll be using it throughout A-level Maths in the pure section. So let's have a look at these two questions. What I'm going to do is I'm going to call this question 1, this one here, and we'll call this one question 2. So let's have a look at question 1 first. So P is equal to 3a plus 5 divided by 4 minus a. Now I want to make a the subject of this formula. The difficulty here is I've got an a in the numerator and I've got an a in the denominator. So the first thing I need to do is get this a out of the denominator here, and I can do that by timesing through. So the opposite of dividing by 4 minus a is to times both sides by 4 minus a. So what I get here is p times 4 minus a, which is equal to 3a plus 5. Okay, that's my first line of working there. Now, I just want a as a subject. So what that tells me is that I need to isolate the a's on one side of the equation. I've got an a on this left-hand side here in the bracket. We've also got this 3a on the right-hand side. So what I'm going to have to do here is expand this bracket on the left-hand side, collect the a's on one of the sides, and then just factorise basically. So this would be 4p minus AP is equal to 3a plus 5. So like we just said, we need to get the a's on one side now if we want to make a the subject. It doesn't matter which way you do this, so you can take the 3a onto this side if you want, and then take the 4p obviously onto the other side. That works. Or you can take the AP onto this side. In my experience, it's easier to take the negative one usually across and keep everything positive if possible. So what I'm going to do here is I'm going to take this AP across and I'm going to subtract this 5 because I only want a's on this right hand side. So I'm going to get 4p minus 5 is then equal to 3a plus AP. Okay. If you prefer, you can write this the other way around so people find it easier to visualize. So that's 3a plus AP is equal to 4p minus 5. That's one way you can do it. And then at this stage here, we just want a as a subject. So we've got a's only on the left hand side here. So all I need to do is factorise. So factorising this a out, that'd be 3 plus p on the left hand side. This is still equal to 4p minus 5. So therefore, to get a here, we just need to get rid of this 3 plus p. And because we are multiplying here, we just do the opposite, we divide. So therefore, we finish it off over here. A is equal to 4p minus 5 divided by 3 plus p. Okay, and there we go. So we've made a the subject there. So that was question 1. Let's take a look at this question 2 now, which is definitely much trickier than what we've just done. And the reason this one's a lot trickier is because we've got these fractions all over the place. So we've got m over v minus t over b is equal to m minus t divided by r. So we want m as a subject here. So there's a few different ways you can start this. The way I'm going to do it is by just multiplying through by each denominator. So I need to get rid of all the fractions here, and then just simply do what we've kind of done on this question here. So isolate the m onto one side of the equation, and then just factorise, and then just divide through. So it doesn't matter which one you times through by first. I'll do it in a bit of a funny order. I'm going to times through by the b first. So times in everything by b, so that'll be mb divided by v. I'm being a little bit lax here, so this really should be bm. We usually put this in alphabetical order. I'm being a bit lazy. It doesn't actually matter, because obviously multiplication is commutative, so it doesn't matter. I'm just being a little bit lazy. So mb divided by v. If you do t over b and you times it by b, that'll just leave you with minus t. And then this is going to be equal to b lots of m minus t divided by r. Okay, so that's the first line there. Now again, I'm going to keep timesing through by my denominators. So now I'm going to times through by this v. So I'll just write all this out. Okay, so just explain what we've just done. So we had mb over v, so I times through by b then. So times by b. Okay, and you're doing that with each expression here. So mb over v times it by, times it by v, not b. So times it by v, you get mb. I'm going to get minus tv here, and then on this side I get bv times m minus t and divided by r. And then finally, let's times through by r. So what I get here is mbr minus tvr is equal to bv times m minus t. Okay, we're getting close to what we need now. So like we just said, we need m as a subject here, so we need to get all the m's on one side. I've got an m here, so let's just underline what we've got so far. So I've got this m here, and I'm also going to have this m here when we expand. So I need to collect these red parts onto one side. So doing so, the left hand side won't change, that'll be mbr minus tvr. This will be bvm minus bvt. So collecting the m's on one side here, again, doesn't matter which way you take this across. I'm going to take this onto this side, and then this t minus tvr, I'll have to add that to both sides here. Okay, so I'm going to get mbr minus bvm is equal to tvr minus bvt. So at this stage here now, we're pretty much, so at this line here, we're essentially this line here on this one. So all I need to do now is factorise m out of my left hand side. We've got no m's on this side, so that's good. Factorise an m here, and then just divide through by the remaining expression. So that'll be m bracket, so this will be br, because m times br gives me mbr, and then here we'll have a minus bv. This is equal to tvr minus bvt. And then finally, we just want m as a subject, so we finish it off up here. M will be equal to this right hand side divided by this. So what I'm going to get here is tvr minus bvt divided by br minus bv. And there we go. So if you were to look at maybe a mark scheme, they might put the letters in slightly different orders, but again, it doesn't matter. Multiplication is commutative. So as long as you get something of this form or equivalent, then you're good. So that was section 8. So rearranging, very, very important. Make sure this is something that you really are confident with before you kind of step into A-level maths. You'll find it makes it a lot easier. The next section, section B, hopefully this one's quite nice and easy. Just taking a look at expanding and factorising. Again, very, very important. You'll be doing a lot of kind of skills related to this, such as binomial expansion. Factorising is very, very important, just for solving kind of general problems in A-level maths. So the first one, free brackets. So this is something that you might come across when you're doing something like binomial expansion, and you'll figure out in A-level maths a nice, easy way of doing this. At GCSE, you do it the long way, expanding it by hand, but at A-level, you'll learn a nice, quick way of doing it. But it's still an important skill, something you need to be confident with. So if we call this question 1 here, let's have a go expanding 3 brackets. So if I try out the brackets first, it doesn't matter which 2 you multiply first. So what I need to do is pick 2 of the brackets, multiply them, and then multiply it by the final bracket. I personally like to multiply just usually the first 2, and then multiply by the last one. So if I expand this double bracket first, so x times x is x squared, then x times 2 is 2x, 1 times x, that's x, and then finally 1 times 2 is plus 2. So all I need to do here now is clean this up, simplify it, and then we're going to times it by x plus 3. So this will just simply be x squared plus 3x plus 2, and we're timesing all of this by x plus 3. Now at this stage here, what you need to do is take a slow methodical approach to it. So I've got 3 terms on the outside of the bracket, so all I need to do is take this one here, x squared, times it by x, times it by 3. Once we've done that, we've done the x squared term, then we move on to the 3x, so we're going to do 3x times x, 3x times 3, and then finally do the same with the 2, 2 times x, 2 plus 3, and then add everything up together. Once you've done all the multiplication, simplify, like terms, collect everything together, and then what we should get is something in this required form here. So we've got a cubic expression here. So let's have a go at doing this. So x squared times x, that would be x cubed, and then x squared times 3, we're going to get 3 lots of x squared. So 3x squared. So that's the x squared done. So I'm going to give it a little tick to say we've done that one. Now we move on to the 3x. So 3x times x gives us 3x squared. So now all we need to do is 3x times 3, which gives us 9x. So we've done the 3x. And then finally, let's do the 2. 2 times x is plus 2x. And then finally, 2 times 3 gives us plus 6 there. Okay, so we've expanded everything so far. All we need to do now is collect everything together. So we've only got 1 x cubed here. There's no other x cubed terms, so that will just simply be x cubed. I've got a 3x squared here, I've got a 3x squared here, and no more x squareds remaining. So in that case, simplifying these two parts here, I'm going to get 6x squared. 9x plus 2x, that'll simply give us 11x. And we've got the plus 6 at the end. So once we've expanded everything, we get this cubic, which is exactly what we needed. So in that case, a is the coefficient of x cubed, so a is 1. B is the coefficient of x squared, so b is 6. The c is the coefficient of the x, so that's my 11. And then finally d is the remaining constant, which is 6. Okay, so that's our question 1 there. So make sure you're confident expanding 3 brackets like that. It'll come up when you're doing stuff like cubics, plotting cubics, factorising, stuff like that. It comes up quite a bit. So make sure you're confident with them. The next 2 questions here. So we just go to everything so far. We need to factorise this quadratic here. So let's do it in 2 parts. So part A, we need to factorise, and part B, we're going to solve it. So x squared minus 12x plus 27. So I want to factorise this. So remember, factorise, we're putting it into brackets. So we're putting this into brackets here. This is a quadratic, so we should have 2 brackets. This will be 2 brackets. And because it's x squared, I'll have an x at the front of both of these brackets. Okay. Now, I know at some schools and some like colleges and such, it's taught using something called deem. And all it stands for is we times to get the end, and we add to get the middle number. So times to get the end number. So 2 numbers that times give me 27, and then 2 numbers that will add to give me minus 12. Again, this sometimes might just take a couple of goes. So we just need to pick 2 numbers that will times to give me minus 27. So I realise here that my last number is positive, my middle one is negative, so more than likely here what I'm going to obtain is 2 negative numbers. So let's just try minus 9 and minus 3. My 2 numbers. So minus 3 times minus 9 does give me 27, and minus 3 plus minus 9. That's just the same as doing minus 3 minus 9. Gives me minus 12. So in that case, they were my two numbers. And then in that case, all we simply do is x minus 3 and x minus 9. And we factorised it. Okay, so that's part A done there. And part B is just a follow-up. So in other words, it's a hint question, because we're going to use this now, our part A, to solve it. Notice it's the exact same quadratic. All they've done is set it equal to 0. So if this is equal to 0, we're looking for the solutions here. So we're going to get two values. And the reason we get two values is because I've got this part here, x minus 3 is equal to 0. And I've also got this part here, x minus 9 is equal to 0. So imagine just for the first bit, we don't have this x minus 9. I've just got x minus 3 is equal to 0. So in other words, x minus 3 is equal to 0. In that case, what value of x would satisfy this equation? What would solve it? In that case, it would just simply be 3. 3 minus 3 is equal to 0. So x is equal to 3. So that's one solution. But obviously don't forget, we can consider getting rid of the first one and just having x minus 9 be equal to 0. And again, we ask ourselves, what value of x would satisfy this equation? And that'll just simply be x equals 9. Okay? So that's our two solutions there. Don't forget though, this is just simply a quadratic, and what we're actually looking at here, if we understand the intuition, is where does it cut through the x-axis? So I'll plot this here. If I draw just a general quadratic here, let's just say something like this. Okay, my quadratics are pretty terrible, but let's just say that's kind of my quadratic there. What I'm looking for when I'm setting this equal to 0 is this point here and this point here. Where does it cut through the x-axis? So be aware of that fact. That's what we're actually looking for. So that's question 2. And let's have a look at question 3 here. Again, key skills, being able to factorise, just a general kind of term here, and then factorise a quadratic again. So this actually is a quadratic, 8a squared plus 12a, but be careful, this isn't two brackets, and the reason for that is because we're missing our constant at the end. If you actually start factorising this, we're just going to pull out an a and a constant at the front. So the first thing I'm going to do is look at the 8 and the 12. What's the biggest number that goes into both 8 and 12? In this case, I could pull out a 2. 2 would go into 8 and 12. But the biggest number, because we want to factorise this fully, will be 4. So I bring a 4 to the front. And then we look at our letters. I've got an a squared here. I've got an a here. Don't forget that's a to the 1. If we've just got the letter, it's a to the power of 1. And we look at which one's got the smaller power. So it's a to the 1, so that means at most we can bring out an a to the 1, or in other words, just an a. Okay, so 4a goes at the front of the bracket. So what do we need to times 4a by here to get 8a squared? Well, that will just simply be, we don't need the plus at the front. That'll just simply be 2a. So 4 times 2 is 8, and then a times a gives me a squared. So that's the front of the bracket. But we also need this 12a, so what do I times 4a by to get 12a? Well, that'll just simply be 3. Okay, 4a times 3, we get 12a. So that's our factorised form there. And then part B here, we want to factorise y squared minus y minus 2. So if I want to factorise this, again, we're going to split this into two brackets using team. So we need to get two numbers that will times to give me minus 2, but we'll add to give me, so be careful here, we don't actually write it, but there's a minus 1 here. Okay, minus 1y. So times to give me minus 2, but we'll add to give me minus 1. So the two numbers I'm going to try here. Again, it might take a couple of goes to get this. So let's just say I pick minus 1 and 2. What will that give us? So if we were to try this, 2 times minus 1 is minus 2. So it works for multiplication. But if we do 2 plus minus 1, in other words, 2 minus 1, we get 1. So that's not quite right, but this is pretty close. So what I'm going to try here, so it doesn't work for this one, but let's try minus 2 and 1. Minus 2 times 1 gives me minus 2, and minus 2 plus 1 gives me minus 1. So we've got our two numbers there. So in this case, this would factorise to be a y at the front of both brackets again, because it's y squared. And then in each bracket I'll have a minus 2 and I'll have a plus 1. So it's essentially just whatever two numbers we pick out here. Okay, so there we go. That's section B, taking a look at expanding and factorising. Section C is surds, which can cause a lot of issues for quite a few students. But again, this is a very important skill. It will come up quite a bit in your A-level maths. For example, taking a look at stuff like differentiation, solving equations, it might crop up. So it does come up quite a bit. So first here, let's call this question 1. I want to work out the value of root 12 minus root 3 all squared. So there's two ways you can actually do this. I can write this as double brackets and expand the brackets, or there's a nice little quick trick you can spot, which if you notice, root 12, we can simplify that. So I can write root 12 as root 4 root 3. So root 12 is root 4 root 3, and root 4 simplifies to be 2. So this is 2 root 3. So what I've actually got now is 2 root 3 minus root 3 all squared. Well, let's just simplify to the inside of the bracket. If you've got two lots of root 3 and we subtract minus root 3, so that's minus 1 root 3, 2 minus 1 just gives me 1. So what I've got here is the square root of 3 all squared. Some people just remember the fact that if you square a square root, we just get left with whatever's underneath, which in this case would just give us 3. But a more mathematical approach, and I think would aid in intuition here, is if we consider this as powers. So root 3, that's the same as 3 to the power of a half. Okay, this is something we should know from indices. So 3 to the power of a half, if we square that, so the square root of 3 squared, that's 3 to the half times 3 to the half. Remember, when we're timesing with the same base, so we've got 3 here, we've got 3 here, all we do is add the powers. So what I get now is 3 to the power of a half plus a half. A half plus a half is just simply 1. 0.5 plus 0.5 is 1. So what I get here is 3 to the 1, which is equal to 3, which is what we got here. Okay, so if you can just remember the fact that if you square a square root, you just get left with whatever's underneath. That's good, that does work. But I think understanding the intuition here, the square root, power of a half, so if we square it, we're just gonna, the power is just gonna add to 1. Okay, so that was question 1 there. So let's just split this off. Let's take a look at question 2. So I'm calling this one here question 2. So root 5 times root 8 plus root 18. We want to show that this can be written in the form a root 10, and a is just an integer. So remember, an integer, just a whole number. It can be positive, can be negative, just a whole number. So for this question, I think the easiest way to do it is just to expand this out, this bracket out. So root 5 times root 8, remember when you multiply two square roots together, two surds together, this would just be root 5 times, so it'd be root 5 times root 8, which is the same as doing it under one square root, like that. So that would be root 40. And then doing the same here, this would be 5 times 18, which would be root 90. So root 40 plus root 90. Well, at this point here, this is nowhere near what we want, because I've got root 40, I've got root 90. They want a root 10. But it's actually closer than it looks. And the reason for that is because we can simplify both of these to be root 10. How can we split this up? Well, let's think of a square number. So a 4 would go into this, square root of 4. And what do I times this by? We times that by the square root of 10. Root 4 times root 10 gives us root 40. Perfect. This is what we're looking for. We're looking for root 10. So essentially think about doing 90 divided by 10. So again, that would be root 9, root 10. But we can simplify each one of these individually. So square root of 4 is 2. So this side is 2 root 10. Now dealing with the root 9 root 10. Root 9 simplifies to be 3. So this is plus 3 root 10. And then we just want it in the form a root 10. So we need to collect like terms here. But really we're not collecting like terms. We're just simplifying the surds. So 2 root 10 plus 3 root 10 will just give us 5 root 10. Okay, so therefore a is just simply the 5 at the front of the root 10 here. Okay, so then the 2 questions there. Now let's take a look at this last one here. A little bit trickier. If we call it question 3, we'll do it up here. We want to show that 6 minus root 8 divided by root 2 minus 1 could be written in the form a plus b root 2. Okay, and a and b are just integers that we're going to find. So again, we should expect whole numbers here. So we shouldn't be getting any fractions. If we get fractions, we've probably done something wrong. So it doesn't actually tell you what it wants you to do here. You need to understand what's going on. Now, if I just end up with something like a plus b root 2, we've got rid of the denominator. And the way we get rid of the denominator here is by rationalising. So this should be something that you are familiar with, rationalising the denominator. The trick with this one is this is a bit of a tricky one because I've got this square root of 2 minus 1. So when we rationalise this denominator, we need to multiply by the conjugate. So we multiply by the conjugate. So we multiply by conjugate. So what does that mean? Well, if you've got root 2 minus 1 as the denominator, we times through by root 2 plus 1. Okay, so it's the opposite sign here. Obviously, if that was root 2 plus 1, then we times by root 2 minus 1. So you always do the opposite sign here. Okay, so let's try doing that. So 6 minus root 8 times root 2 plus 1. Then we're going to do the same here. This will be root 2 minus 1 times root 2 plus 1. So I apologise, I got rid of the times there. But we are just times them. So you can write them as 2 brackets literally together. But just to make sure the idea is clear, we're just timesing these together. So all I need to do now is expand both of these brackets. So 6 times root 2, that would give me 6 root 2. 6 times 1 is 6. Minus root 8 times root 2. So just be careful here. So it's a negative number times a positive number. So my final number will be negative. So this is minus root 16. And we can simplify that, but we'll just wait 1 second. And I've also got a minus root 8. So minus root 8. So let me just write this all on one line. So I've got 6 root 2. We've got the plus 6. Minus root 16. So root 16 is 4. So this is minus 4. And then finally we've got minus root 8 there. Okay, so that's my numerator. The denominator, so what should happen here, the reason this rationalising works so well is because we get rid of the square roots in the denominator. So this should just be a whole number of some sort in the denominator. We shouldn't be getting any surds. So root 2 times root 2, that will just simply give us root 4, which is 2. So again, if you square a square root like we've just done, you just get whatever's underneath. So we get 2. I get plus root 2. Minus 1 times root 2 is minus root 2. And then finally, minus 1 times positive 1 is minus 1. So all I need to actually do here is start simplifying. So in the denominator, this root 2 will cancel with the minus root 2. So my denominator will just cancel to be 1, because 2 minus 1 is 1. So what I've actually got now, if we do it right at the top, I'm running out of room for this one, it's quite a long one. 6 root 2. 6 minus 4 is 2. And we've got this minus root 8. We just need to simplify that root 8. Because notice, the final answer is just a plus b root 2. So I need to be able to bring this root 8 into something root 2. Well, if you divide 8 by 2, that'd be 4. So this can be written as root 4 root 2. And root 4 is simply 2. So the square root of 8 is the same as 2 root 2. So I've got 6 root 2 plus 2 minus 2 root 2. Okay, and then this is all divided by 1. That's just what we worked out for our denominator. So simply, all we get left with here is 6 root 2 minus 2 root 2. So that's 4 root 2. And we've also got our plus 2 there. So they've got it in the other way around. So they've got a plus b root 2. So in that case, that would be 2 plus 4 root 2. Okay, that's exactly how they've got it. So that's our final answer there. Okay, so like you see, them questions can be quite long. You've got to be careful. The maths can be a little bit tricky in it. But with enough practice, hopefully you shouldn't find them too bad. Okay, so that was a brief look there at Surds. Let's take a look at the next topic now, section D, which is taking a look at indices. Again, very, very important. This will come up massively when you're doing differentiation, integration, so a lot of calculus. It's very, very important. So let's take a look at this first few questions here. So I'm calling these 3 here question 1. So A, we want to write down the value of 36 to the power of a half. Remember what we've just done before? Power of a half is the same as the square root. So all I'm going to simply do here is take the square root of 36. Square root of 36, that's just 6. So that's nice and easy. Part B, 23 to the power of 0. Over the years, I've heard tons of different kind of answers given for powers of zeros. I've heard 0, I've heard other crazy things, but it's none of them. Anything to the power of 0 is just simply 1. Okay, doesn't matter if it's a letter or a number, anything to the power of 0 is always 1. So that's part B done. And then finally, let's take a look at this part C here. 27 to the power of minus 2 over 3. So this one's not easy. There's a few different things going on here. First, the way I like to deal with this is to get rid of this minus power. So when you've got a negative power like this, we need to look at the reciprocal. So we technically write this over 1. So this is 27 to the minus 2 over 3 divided by 1. We don't always do it, but under every number we can divide it by 1, that fraction of 1. So what I do first is I flip this fraction. So this becomes 1 over 27, and then my power, instead of it being negative, it becomes positive. So this is 2 over 3. So that's my first line of working. Next, let's deal with the denominator of the power. So this bottom number tells us what root we're taking. So first, we take the cube root. So because it's the power, because this is a 3 here, we take the cube root. If it was 4, we'd take the 4th root. If it was 2, you'd take the square root. So because it's 3, we take the cube root of 27. So let's just write that down. So we take the cube root of 27. And then this numerator for our power tells us what we then raise that result to. So because that's 2, all that means is we square the result. So what's the cube root of 27? Well, that would simply be 3. 3 times 3 is 9. Times that by 3, we get 27. So this becomes 1 over 3 squared. And 3 squared, we know, nice and easy, is 9. So what we get for our final answer is 1 over 9. Okay, so that's part C there. So again, can be tricky at first, but with enough practice, these questions should become pretty standard and hopefully not too bad. So that's part C there. So let's just clear all these and we'll take a look at the next question. So this one here, I'm going to call this question 2. I want to work out the value of 16 over 81 to the power of 3 over 4. So pretty similar to what we've just done here. What makes this one slightly trickier is that we've got this quotient, this fraction, 16 over 81. But the working is the exact same for the power. So what we do first is we look at the denominator. So because that's 4, we're taking the 4th root of top and the bottom. So what will this look like? So this will be the 4th root of 16, and we divide that by the 4th root of 81. And then we're going to raise both of these to our numerator, which is 3. So we're going to cube each of these. Okay, so there's a lot of brackets. It looks a little messy. Just take it step by step first. So what's the 4th root of 16? So what number do I times by itself 4 times to give me 16? For this one, that would be 2. So 2 cubed is 8, times it by 2 again gives us 16. So my numerator is 2 to the power of 3. We need to do the same here with the denominator. So what's the 4th root of 81? A little bit trickier, but hopefully you shouldn't find this too bad. So think about cubing numbers now. The cube of 3 is 27. So if I times 27 by 3 again, I actually get 81. So what I've got in the denominator is 3 cubed. So simply, all I need to do here is cube each of these numbers. So 2 cubed is 8, and then 3 cubed is 27. So our final answer is 8 over 27 for that one. Let's take a look at this one then. If we call this one here question 3. So I've got 3 different numbers given to me. I've got 3 to the power of a is 1 over 9. I've then got 3 to the power of b, which is 9 root 3. I've also got 3 to the c, which is 1 over the square root of 3. And we're asked to work out the value of a plus b plus c. So to work out a plus b plus c, we need to work out each power individually. So I think the easiest one to start with is a. So a, we're looking for this power. So 3 to the power of something is 1 over 9. So the way we're going to deal with this first is consider this right hand side. So 1 over 9, think about how we'd write this as a power of 3. Well, how do you link 9 and 3? Well, 9 is 3 squared. So what I've actually got here is 1 over 3 squared. And remember, when we do this here, this is similar to what we did with this one. If you flip this, so essentially this was 3 to the minus 2 over 1. What this actually becomes then is, like we just said, here's 3 to the minus 2. If you've got 1 over 3 squared, this would actually be 3 to the minus 2. Okay, so in that case, therefore a is minus 2. So now, again, let's work out, I think probably the next easiest one is probably c. So if we work out c then, again, consider the right hand side. So I've got 1 over the square root of 3. The fact that this is a 1 over again suggests to me that the power is going to be negative. All I need to do first is consider this root 3. So remember what we just said. Root 3 is 3 to the power of a half. And then the fact that this is 1 over means that this is going to be 3 to the minus a half. Okay, this is just 3 to the minus a half. So in that case, c is minus 1 over 2. So the only thing left to work out here is b. So b has 2 parts to it. We've got the 9 and then the root 3. So let's do that over here. 9 root 3. So this is 2 numbers being multiplied. So all I need to do is link both of these to our base here, 3. So 3 and 9 link as 3 squared. So what I've got here is 3 squared. And root 3, we've already linked that one here. That's 3 to the power of a half. So this is 3 squared times 3 to the power of a half. So again, using our rules of indices, if I've got the same base here, so both of them are 3, I've got my powers, all I need to do is just simply add the powers here. So 2 plus a half is 2.5, or we can write that as 5 over 2. So this is 3 to the 5 over 2. So in that case, b is 5 over 2. So all I need to do now is work out what a plus b plus c is. So to do that, I just need to add all of them together. I think the easiest way to do this is just to add b and c together first. So I kind of run out of room here. Let's do it over here. So b plus c. So that's 5 over 2 minus a half. So that just leaves me with 4 over 2, which is 2. And then 2 plus minus 2 is 0. So in that case, A plus B plus C is simply 0. So I've done all that work for absolutely nothing because it just comes to 0 anyway. But there we go. So A plus B plus C is just simply 0. And then let's just take a look at this very last one. We've got 9 to the 3x plus 1. We can say this is 3 to the power of y. So we call this question 4 here. So how do we link 3 and 9 again? So like we've just been doing, 9 is 3 squared. So 9 is 3 squared. So what I'm going to do is just rewrite this first. Okay, so that's just how we've rewritten it. So I've just replaced my 9 with 3 squared. Here now we use our rule of indices again. So if you've got a power raised to another power, all we do is multiply those two powers together. So this gives me 3 to the power of 2 times 3x plus 1, which is simply 3 to the 6x plus 2, which is equal to 3 to the y. So in that case, our y, so it sounds very obvious, but if these two bases are the same and they're equal, then the powers just simply must be equal to each other. Y must just be equal to 6x plus 2. So if we just write that out as they're asking for in the question, that would be 6x plus 2 there. Okay, that's exactly what we've got to show. So A is 6, and then B is 2. Okay, so that's section D fully complete there. Carrying on working our way through here now, we're on section E, looking at proof questions. At A level, you look at some more examples with proof, such as proof by contradiction. But at GCSE, we're just proving some basic ideas here. So, 3 different examples here. If we just get the right pen colour, what I want to do here is prove that the square of an odd number is always 1 more than a multiple of 4. So, I've got a black pen, I normally write in white. There we go. So question 1 here, if I want to prove that the square of an odd number is always 1 more than a multiple of 4, well, we need to understand how we define an odd number. So the easiest way is to start with our very first even number. So the easiest way to do that is say 2k, where k is just a number, okay? In this case, because it's a multiple of 2, will always be even. So my next number, 2k plus 1, must be odd. So that's even. In that case, 2k plus 1 will be odd. So if that's odd, we want to prove that the square of this number, so let's square this, 2k plus 1. What do we get? Well, this would be expanding double brackets here. So that would be 2k plus 1 times 2k plus 1. This is something you'll get much quicker with more practice. But 2k times 2k would be 4k squared. I've got 2k times 1 here, so that's 2k plus another 1 times 2k. So that's 2k plus 2k, which is 4k, and then 1 times 1 is 1. Now, this is pretty close here. The only thing I need to kind of show here is that this part here is a multiple of 4. And how would we do that? Well, let's factor out that 4. So factoring out that 4 there, I get k squared here. 4 times k squared is 4k squared. And then finally here, this would be plus k. Okay. And I've got my plus 1 at the end, let's not forget that. Now this part here is a multiple of 4. So if we have a multiple of 4, and we have this plus 1 at the end, this is always 1 more than a multiple of 4. And this is exactly all we need to show. Okay, so if you can show that this part here is a multiple of 4, if we add 1, then it's always 1 more than a multiple of 4. Okay, so not too bad, I don't think. You know, just these ideas. Again, you need to be confident with the language. So if we take a look at this second question here, so I'm calling this one question 2. This one here. we want to prove algebraically that the sum of a half n times n plus 1 and a half n plus 1 times n plus 2 is always a square number. So we just need to understand what the sum of means. So remember, the sum of is just a slightly posher way of saying add together. So what do we get when we add this and this expression here? Well, let's take this step by step. So for me, the easiest way to see that we can tackle this is if I expand each one separately. So a half n times n plus 1. We'll first just do n times n plus 1. So that'd be n squared. So n squared plus n. But then we're timesing each one also by a half. So if you times each one individually by a half, that's the same as just dividing by 2. So n squared divided by 2. We also have n over 2. Okay, so that's that one done. Let's do the same here now with this a half, n plus 1 and n plus 2. So again, I'm going to expand the double brackets first. So that'd be n plus 1, n plus 2. So that'd be n squared. I'll get a 2n here, n times 2, and then 1 times n. So adding them together, that's 3n. And finally, 1 times 2 will give us 2. So this is what I obtain here, but then don't forget, we've got this half at the front. So I need to divide each one of these individually again by 2. Okay, this 2 over 2, this would individually become 1. 2 divided by 2 is 1. So writing this out in full, what I've got here is another n squared over 2. I've got 3n over 2. And I finally got 2 over 2, which is 1. So let's start collecting things together here that we can. N squared over 2 plus n squared over 2. So essentially that's a half of n squared plus another half n squared. And in that case, what I'd get there is just n squared. Okay. N over 2 plus 3n over 2. So that would be 4n over 2. And 4n over 2 would simply be 2n. So that's 2n. So I've dealt with that and that. Dealt with that and that. We've got our plus 1. So here now, we've got this expression here, this quadratic. But we want to show that this is always a square number. So how does this show us that this is a square number? Well, if I could write this as the product of, for example, itself again. So if I can factorise this, and I obtain, say, a here, and this is a squared, then it would be a square number. So the front of these will be n, and that'll be n. And then factorising this, so this is what we did earlier on in the video, this would simply be plus 1 and plus 1 again. Okay, so n plus 1 times n plus 1, which is actually just the same as n plus 1 squared. So therefore, square number. And there we have it. Okay. So that's our question 2. And if we clear all this, let's have a go at the very last question. So here I want to prove algebraically that the sum, again, so adding together, the sum of any two consecutive integers is always an odd number. So again, just like we started with the beginning here, the question 1, if I take my first number as just being 2k, which is even, and my next number, which is odd, is 2k plus 1. So these are consecutive, so they must follow each other. Obviously, you could pick any two consecutive integers here. So for example, I could do 2k plus 3, 2k plus 4, 2k plus 10, 2k plus 11. Doesn't matter as long as they are consecutive. So in this case then, if we add these together, we want to show that this is always an odd number. So 2k plus 2k plus 1, what would that give us? Well, that would just simply be 4k plus 1. Okay, so 4k plus 1. Well, how do we know this is an odd number? Well, this 4k here, we could actually write that as 2 lots of 2k. Okay, so this is now a multiple of 2. It's in the 2 times table. And remember, any number that is a multiple of 2 will always be even. So what I've got here now is this part is even, because it's a multiple of 2. And this 1, obviously 1 is an odd number, so that's odd. So remember, if you have an even number, so even plus odd, what that will actually give us is an odd number. And you can try that with any couple of examples. Say take 2 plus 1, nice easy example, that's 3. And 3 is odd. Again, pick another example. Let's pick 6 and 11 is my odd. 6 plus 11 is 17, which again is odd. Now obviously these two examples don't prove it, but this result here does. Okay, so that's how we've given the proof there. So that's section E, taking a look at proof. Let's take a look at the next section then. So section F, we're taking a look at completing the square. Let's call this one here question 1. So a very standard example, you're given a quadratic. We want to write it in this form, which doesn't tell you what method you're doing, but when you see that notation, you should be realizing that this is completing the square. So x squared plus 2x minus 8. Well, we can write that in this form here. So how do we do that? Well, what I do first is I divide this middle term here by 2. We're halving it. So that's going to be, and we take this here, this x squared, and we just write as they give us as x. So this is going to be x plus 1, so it's half of this here. We close the bracket and we square it, just like they've done. So our m in this case is 1. What we do now is we square this number here, our m, and then we take the negative of it. So what's the square of 1? Well, that would just be positive 1, and then we take the negative of that. So that's minus 1. And then we include whatever's left here. So that's minus 8. Simplifying this, I'm going to get x plus 1 all squared. Minus 1 minus 8 gives us minus 9. Okay, and there we have it. So that's our complete the square form, which is exactly what they want here. Okay, that's what we've got there. So nice and easy. Like you can see, m is 1 and n is minus 9. Perfect. Let's take a look at this one here. In fact, let's actually have a go at this one. So if I just change my pen color to black, we can write actually on this page here. So we've got x squared minus 8x plus 21. And again, we want it in this form that they've given us. Don't worry about the fact that this is minus a here. They're just accounting for the fact that this is a minus x term here. So we're going to complete the square again. So just like we've done here, we start off by doing the bracket. We half the coefficient here. So what's half of, well, minus 8, that would be minus 4. We write minus 4 there. We square this. We square this and take the negative of it. So minus 4 squared would be 16. But we want minus 16. And then we add the 21. Okay. So 21 minus 16. So what that actually gives us here is 5. So this is x minus 4 all squared. And then 21 minus 16 is plus 5. Okay. So we've simply got it in the form that we needed then. So a in this case, this is minus a. So this is minus 4, then a is 4. So be very, very careful. Don't write minus 4 there. This is just 4 in this case. Okay. And then finally b is just the very last term, which is this here. So b is 5. Okay. So pretty standard there. Part B, just the one marker. If you can actually complete the square here, then your answer is pretty much on the screen. So remember, the minimum point is the point here, like we demonstrated, this point here. Okay, I've kind of butchered the cross, but that's where it is. So it's where the graph is turning, essentially the turning point. Now, if we look at the quadrant here, this is a positive x value and a positive y value. So if I randomly get a negative x value here, we know it's wrong because it's not over in this quadrant. So, based on that fact, we need a positive x, positive y value. And we use the completed square form. So we've got x minus 4 all squared, and we've got plus 5. So this part here corresponds to the x coordinate. So this corresponds to x coord, and this part here corresponds to the y coordinate. So how do they correspond? Well, this plus 5 tells you how many units up. So this is 5 units across. Okay, so that's 5 units there. So my y coordinate is 5. The x coordinate is this value here times by minus 1. So minus 4 times minus 1 is 4. So minus 4 times minus 1 is 4. So my x coordinate is 4. Okay, so we're 4 units along. Okay, so 4, 5 is our coordinates for M. And then finally, this other one here, this question 3, it follows pretty much the exact same method as we did here. We just don't have a graph to help us. But the method is exactly the same. So let's just write down our quadratic. So again, let's find the completed square form of this. So just like we've done for question 1 and question 2, we write our bracket with an x. We halve the coefficient here, so half of 10 is 5. So that's x plus 5. We close the bracket and square it, like so. We now square this term here, and then times it by minus 1, or take the negative. So 5 squared is 25, so that's minus 25. And then we include our original, plus 3. So writing this out in the appropriate form, this is x plus 5, all squared, minus 25 plus 3, minus 22. And now, what we've got here is exactly what we had down here. We've got our completed square form. All we need to do now is identify the coordinates. Well, we just take a look at what we've got here. We take this point here and times it by minus 1. So that would be minus 5. And then this is just our y coordinate, so minus 22. Okay, so that's our minimum point there. Minus 5, minus 22 of the curve. Y equals x squared plus 10x plus 3. So that's section F done. Let's take a look at section G now, taking a look at straight lines here. So this can be a tricky issue for some students. Some find this quite easy, some find this quite tricky, but it will come up quite a bit in your A level. So it's important that you kind of get to grips with it now. So let's call this one here question 1. So this one hopefully is the easiest of the 3 on this page. We've got 2 coordinates. We've got 0, minus 2. And we have 3, 10. Okay. What I want to do here first is work out the gradient. So remember, we're looking for something of this form. Y equals mx plus c. Remember, m corresponds to the gradient. And c corresponds to the y-intercept. So all I'm looking to do here is calculate the gradient using my 2 sets of coordinates here, and then the y-intercept is actually already given to us if you look at the diagram. We've got 0, minus 2, so it cuts through the y axis here at minus 2. So that we don't need to worry about. If we didn't have that, we would have to calculate that as well. But for this one, nice and easy, we just need to calculate the gradient. So how do we calculate the gradient? Well, we can use a nice easy formula. I'm going to call this y2. So in that case, this is y1. And then similarly, this must be x2. And this must be x1. Okay, so we just need to assign the coordinates appropriately. You can do it the other way. Just be consistent. If you called this y2, that would be y1. And that would be x2. That would be x1. But it doesn't matter which way around we do that. So here now, all I do is I use the formula y2 minus y1 divided by x2 minus x1. So it's a change in the y coordinates divided by the change in the x coordinates. So all we need to do is simply calculate that. Y2 is 10, y1 is minus 2. So be careful here, this is y2, which is 10, minus y1, and y1 is minus 2. So this is 10 minus 2, so we have to be very careful there when we calculate that. And then x2 is 3, and we minus 0, so that would just be 3. So 10 minus 2, that would be 12. 3 minus 0 is 3. So 12 divided by 3 is 4. So my gradient is 4. Okay, gradient of 4. So in that case, the equation of the straight line will be y equals 4x, because m is 4, so 4x. And then my y-intercept, we already said, is minus 2. Okay, so that one's quite nice and easy. Like I said, if we didn't have where it cuts through the y-intercept, we would have to work that out using substitution, but for this example, nice and easy, we don't need to worry about that. Okay, so that's that question there. Let's take a look at this one here, where we're going to show that the line 3y is equal to 4x minus 14 is perpendicular to this other line. So how would we do that? Well, we need to understand the definition of perpendicular. So if you've got a gradient, say 2x, or a gradient of 2 I should say, so let's write that down again. So m is equal to 2, that's my gradient of 2. This would be perpendicular to a gradient of minus a half. Okay, so what we do is we take the reciprocal, so that would be 1 over 2, and then we times that by minus 1. So the perpendicular, if you can show that fact. So let's write both of these in the form where we can work out the gradient. So 3y is equal to 4x minus 14. So the gradient then, so we only care about the gradient here, so we don't need to bother working out anything to do with the y-intercept. The gradient here will be 4 divided by 3. Okay, so m is 4 over 3. Let's do the same with this other line. So 4y is equal to minus 3x plus 48, but again, we're not bothered about that fact. We only care about the gradient. So in that case, we divide by 4 here. That would be minus 3 over 4x. And then in that case, m is minus 3 over 4. So if we take this m value, what would be the reciprocal of this? Well, that would be 3 over 4. And then if we times it by minus 1, we should get this, which is exactly what we get. 3 over 4 times minus 1 is equal to minus 3 over 4. Therefore, the perpendicular. That's all we can need to show there. Okay, so therefore, perpendicular. Nice and easy. So that's that question done. Now let's take a look at this very last one here. So we've got a circle, a centre row, and we've got this tangent here demonstrated here. So what I'm going to do is write this in black. So we've got this tangent here, and we know the point P is 4, 3. So this is 4 units along here. That's 4. Ignore my kind of bad artwork. So then this would be 3 units up. Okay. So that's 3 there. So we have the centre here. This is 0, 0. Now, if I want to find the equation of this tangent, what I'm going to need here is the gradient of that line. We already have the point which passes through it. So if we can just work out the gradient, we can easily work out the equation of the tangent. But first, I need to work out that gradient. So how would I do that? Well, what I could do here is work out, say, from the origin to that point there. If we can work out this gradient, then the point P is perpendicular to that, with it being a tangent. So let's work out the gradient of this line here from the origin to P, work out that gradient, and then times that by, well, minus 1, and then take the reciprocal. So let's see if we can do this in black. Question 3. It's looking a bit too dark. Let's change it again. So the gradient, m, would simply just be 3 minus 0 divided by 4 minus 0. Okay, so that would be a gradient of 3 over 4. So that's fine. We get a positive gradient there, which is what we would expect. So now we need the perpendicular gradient. So we'd flip this. That would be 4 over 3. And then we're going to times it by minus 1 to give us minus 4 over 3. So the gradient of the tangent is minus 4 over 3, which again we should expect a negative gradient there. So we've got the gradient. All I need to do now is use the point that we've got, which is 4, 3. There's an easier formula for this. So if we use the formula y minus y1 is equal to m lots of x minus x1. Well, y1 and x1 are the points that we already know. Okay, so in that case, we've got 4, 3. That's my x1, and that's my y1. So hopefully this is something you have been introduced to before if you're a strong GCSE Maths student, something you've been shown in class. If not, it might look a bit new, but it's not too bad. It's a lot easier to use, and it's something you will use a lot in A-level Maths. So y minus y1, so that's y minus 3, is equal to m, where m is the gradient here, so this is minus 4 over 3, times x minus x1, so minus 4. So at this stage here now, we just need to start doing some calculations and make this a bit easier to look at. So to do that, what I'm going to do here is just deal with this right-hand side with the fraction and the bracket by expanding. So I'm kind of running out of room, so let's just clear some room first. So let's clear all this. So I picked the wrong pen colour again. I'm having a bit of a nightmare. So let's do this up here. So this is y minus 3. This is equal to minus 4 over 3 x. Or you could write that as minus 4x over 3. Either's fine. And then this would be positive 16 over 3. So just be very careful there. Positive 16 over 3. So just like we've been doing for regular kind of GCSE maths, I'm going to write this in the form y equals mx plus c. And given that we don't need to write this in a specific form, we're not going to worry about the fact that we've got fractions here. So all I need to do now is add 3 to both sides. So y is equal to minus 4 over 3x. 16 over 3 plus 3. Let's just do that in a bracket first. So 16 over 3 plus 3. So I'm doing this by hand. You could just use a calculator. But I could write this as 9 over 3. And then 16 plus 9 is 25. So that's 25 over 3. So my actual final answer here is y equals minus 4 over 3x plus 25 over 3. Okay, and there we go. So that's our equation for the tangent. So this is your y-intercept. That's my y-intercept. And that's my gradient. Both of them look sensible. So if you were imagining where this cuts through on the y-axis here, cuts through at 25 over 3, somewhere up here, or maybe there, somewhere roughly around there. Okay, so there we go. So that's that section done. And now let's move on to the very final section here. Take a look at functions. So this is something that's quite new to the GCSE Maths spec. And again, it's very, very important at A-level. It's something you'll come across a lot when you're dealing with differentiation. There's a full section on functions at A-level Maths, so good practice. And these skills, you know, if you're confident with them now, you'll find the functions that you do at A-level a lot easier. So this first question here, we're given two functions, f and g. First part, we want to find the value of f of 10. So f of 10. How would we do that? Well, if I've got f of x is equal to 3x minus 4, if I've got f of 10, I just replace x with 10. So this becomes 3 bracket 10 minus 4. So just replacing my x with 10. And then all we need to do is actually calculate this. So do the bracket first using BIDMAS. 10 minus 4 is 6. So this is 3 times 6. And nice easy now. 6, 12, 18. So that answer is 18 there. So that's just finding the value of a function. Part B, testing whether you know how to find the inverse of a function. So at GCSE, the functions that you will typically work out and the inverse of them functions are quite nice and easy. At A-level, you come across some trickier ones, but at GCSE, hopefully, should find it quite nice and easy. So first, let's just write the function out. So g of x is x over 5 plus 1. Now, there's a couple of different ways of doing this. The way I was taught this is to change g of x now to y. So it becomes y equals x over 5 plus 1, just like that. And what I'm going to do now is rearrange and make x the subject. So make x the subject. That's the goal here. So practicing rearranging again, another topic that we've practiced through this video. I'm going to times, in fact, before I times anything, let's take this positive 1 across. So I get x over 5 is equal to y minus 1. and then I'm going to times through by 5. Remember, we just want x, so what's the opposite of divided by 5? Well, that would just be times by 5. Okay, so times in by 5. X over 5 times by 5, that would just give us x. And y minus 1 times 5, so that's 5 lots of y minus 1, which we could write as 5y minus 5. So that's all good. All we need to do now is change the notation. So we're looking for the inverse. This is in terms of x, so all I'll do is replace my x here with g inverse, because that's what we're calculating, g inverse of x. And remember, this function has to be in terms of x, so wherever there's a y, we replace that with the variable we're working with, which is x in this case. So it's 5x minus 5. And there we go. So that's our inverse there. So nice and straightforward. Part C, a little bit more work to it. Let's do that up here. So this is the composition of functions. So f is going back into f of x. Now we know what we need to get at the end. We need to get 9x minus 5a. So we'll know whether we've got it right or wrong when we've done the question. So f of x is 3 bracket x minus 4. Now, if f is going back into f, all I need to do is substitute f into f of x. So wherever there's an x, replace it with f of x. So it's going to look a little bit messy, but stick with it. So this is going to be 3 bracket. We've got an x here, so I need to substitute f of x into that. So that's going to be 3 bracket x minus 4. We close that bracket, and then just don't forget, we still need this minus 4 at the very end here for our original function. What I do here is I clean up the inside of this bracket. So this would be 3 lots of 3x minus 12. And we've still got this minus 4 at the very end. Clean up the bracket again. Minus 12 minus 4 is minus 16. So this is 3 lots of 3x minus 16. And then 3 times 3x is 9x. And then 3 times minus 16 would give us minus 48. Which is exactly what we needed for the answer there. Okay, so happy days, we've got the answer. So that's the question 1 done, and then let's take a look at this one here. It says question 10, but just ignore that, we'll call it question 2. So, 2 actual little parts of this, not too much work. We want to find f of 23. So f of x is 4 sine x. So if I want f of 23, all I'm doing is replacing x with whatever this value is. So in this case, replacing it with 23. So it becomes 4 sine 23. So all you need to do now is literally plug this into your calculator. You wouldn't be expected to do this by hand. Obviously, we're asking for it to 3 significant figures, so make sure you round it appropriately. If you put this in your calculator, what you should get here is 1.56 there. Okay, so that's for f of 23. And then part B is easy as it looks. So again, composition of functions, but this one's a nice easy example. And the reason for that is because we're combining g of 34 or f of g of 34. So in that case, remember we work backwards with functions like this for composite functions. So we calculate g of 34 first, and then we substitute that into f. So it's a bit funny with functions, we work from right to left rather than from left to right. So a bit backwards. But if we calculate g of 34, that's going to be 2 times 34 minus 3. So this would be 68. 2 times 34 is 68. Minus 3 is 65. So in that case, we need to find f of 65. And f of 65 is 4 sine 65. And again, just like we did with the first part here, plug this into your calculator, and this would just give you, if you do it correctly, 3.63 there. Okay, so 3 significant figures. And there we have it. So that brings us to the end of this video. Hopefully this has helped. If you're still unsure kind of what to look for, and you're still preparing for A-level maths, check the description. I'm going to leave quite a few links of websites that will help you through your revision. If you know anyone who might find this helpful, like always, share it with them. And if you notice anything that's unclear, or any mistakes that I might have done through this video, because it's quite a long one, please just let me know down below. Any questions, like I said, hit them down there as well. Cheers.